Welcome! In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at efficient array handling and how to measure performance. Today we're going to look at the loading of large data files into arrays and the most efficient way of actually doing it. So in order to achieve this, we're going to use some of the routines we've used previously to generate random information. What we have on screen at the moment are a few basic CSV files. And from these CSV files, we're going to produce a large text file containing the information we're going to load into our array. So the code I've already prepared makes use of three libraries: the Common Display Library, the File Handling Routines Library, and the Random Routines Library. Today we're going to generate 250,000 records within this file to give us a large enough file to test the loading into our array. If we run our program now, we will see it's about to generate our 250,000 records in record time. And there is our data file, about 20 megs in size, and if we open it up, we'll see that it does indeed contain 250,000 records. Now we need a large file in order to test out our efficiency of loading to the array. So we're going to use three slightly different mechanisms to load this entire file into a string array. So this is a point where our file has been generated and is sitting in the data.txt file. And it's here we're going to attempt to load this file into an array. Now in order to test this out properly, we're going to create three separate functions, each slightly different, but each of them with the purpose of loading the file into a string array. So we'll create a first function to load our file in. In order to determine how efficiently we've actually loaded this file, in other words how long it took, we're going to use the tix command. The tix command in PowerBasic is used to count clock cycles. So we will create a local variable as a quad, which is a very large number. And then we'll use the tix command to start the clock running. And then after the call to our function has completed, we will use the tixend command to stop the clock, and we will report how many clock cycles we have actually used up between the beginning and the end of the call to our function. I'm dividing this by 1,000,000 so we can get a nice easy number, which is millions of clock cycles. So let's create our first function. We're going to pass a single parameter to our new function, which is the name of the file we've created, the data.txt file. And this is the file we're going to load into our array. Now we will create some local variables to actually control this. We will create a variable called longFile. This will be the handle to the file we're loading. strRow will be the row we're loading in from the file. Longrow will be the row counter, and the ASTRData is our string array. So in this first attempt at loading the file, the first thing we'll want to do is to obtain a file handle. So the freefile command can be used to give us the next available file handle. And then we can open our file name for input as that file handle. And after we've finished reading the file, we will close that handle down again to free up the resources that were used. And between the open and the close statement, we'll want to read the file. So this first method is going to use a while loop. There is an end of file function that can be used to determine whether we're actually at the end of the file yet, and its single parameter is our file handle. So while this is false, while we are not at the end of the file, we can continue reading from the file. Now we know, since we've created the file, that the format of the file is X number of lines, and at the end of each line is a carriage return line feed. Now the line input command can be used quite easily to read a single row in from that file. It takes two parameters, the handle of the file we're reading and the variable into which you wish to put the data on that line. So we've now read in a single line from the file. We can then increment our row counter, and since longrow started at 0, which is its default value once created, the first increment will push it to element number 1. Now, although we've declared our array up here, we haven't declared the size of the array. So at this moment in time, the array is undimensioned. So we're going to use a redim command to redim the array, to resize it. Now, as this is happening inside the while loop, you'll want to use the preserve option to keep the data that's previously in. Without the preserve option, redimming an array will purge all the information that's in the array. So there's our redim command with the preserve option. We're specifying the array we wish to redimension, and we're saying it from element 1 to long row. So for the first iteration round, this will be an array from element 1 to element 1. And having redimensioned our array, we can put the data we've just read from the file into that element. So this is our first attempt at reading from this file. We will open the file, and while the file is not at the end of the file, we will read one line at a time out of the file, increment a pointer to the array, redimension the array to make it bigger, and to put the data into the array. So if we try compiling that to make sure we've made no errors, and if we try running that now, and it's generating our data, and there's our first output. It's taken 2,883 million clock cycles to achieve the population of the array. Now, despite the fact we were loading 250,000 records into the array, it did load remarkably quickly. But can we improve on that? Let's look at the second method of loading data into the array. So we will create a second function, and we'll put our changes in there. So if we copy the code as it is in the original function and paste it in to the second function, and we're going to make a few minor changes to that piece of code. We're going to introduce a new local variable. This is the total number of records in the file. When you open a file up for reading, you have the option of using the file scan command. The file scan command is very useful. It takes two parameters, one being the handle of the file, which we've just opened, an option to say we want to determine the number of records in the file, and again it assumes here that the file is terminated on each line with a carriage return line feed, and we're sending the total number of records in that file to this variable. So now that we actually know the number of records in the file, we can take the approach of redimensioning the array right at the beginning, so that we don't have to continually redimension the array to put another element in it. So there is our redim command to redimension our array from 1 to the total number of records. So as we're doing that, we don't need to use the redim preserve command anymore, because the array is already dimensioned. So this second function will open the file for reading, scan the file to determine the total number of records within it, redimension the array for that number of records, and then for each line within the file, it will read that into a variable, increment the pointer, and slot the data into that element of the array. And once the file has been completely read, it will then close down the file. So if we're going to make a call to our second method, we can run that now, and we can compare the two methods. And there is the difference. Now for our run here, the first cycle took 3,630 million clock cycles, and our new run is now taking 2,620. So that's a considerable speed up on our first method. So there is one other method we're going to check to see if it's any faster. So as we did before, we're going to clone this second function, and we will create a third and final function. And we'll call that number 3. Now this will be very similar, as we're going to open the file, scan the file for the number of records, redim the array for that size, but rather than using a while loop to actually read each individual line of the file in, we're going to replace all of this with a single command. The line input command can be quite happily used to read an entire file into the array using a single line of code. The only thing you have to do before you actually run this line of code is to redimension the array big enough to hold all the records. So while this method actually involves a lot less typing in your code, is it any faster? Well, we can use our ticks command to determine how fast this is in comparison to the other two methods. So if we clone that and go for number 3, we now have our 3 methods, one after the other. Let's run that and see what values we get now. And there we have it. Method 1, 2,889 million, method 2, 2,594 million, and method 3, faster still, is 2,494 million. So while the time taken to run any function in any application is very much determined on how busy your computer is doing other things, we can see the comparison between the 3 different methods of reading it shows that method 3 appears to be the fastest. So in order to determine whether the computer is actually caching the file we're trying to read, let's create 2 extra files exactly the same. So I've cloned the original data file and created a data2 and a data3 file. So this way the computer will be loading 3 different files which are identical for each of the functions. So we're now calling the original load file 1 with the original data.txt file. And method 2 is calling data2 and method 3 is calling data3. So this should hopefully eliminate any caching. And there are our 3 outputs. Each method is loading an identical file, but a different one. So hopefully this should eliminate Windows caching the files. So the first read, 3,659, second method, 2,600, and the final method using the single line input to the array, 2,507. So there's a considerable difference in speed between method 1 and method 3. So if you're writing an application loading a great deal of data in at one go, obviously method 3 is the most efficient method you want to use. Hopefully you'll find this useful, and you may start using the ticks command within your own applications to make sure that your functions are running as efficiently as possible. But that's it for today. Thank you for watching.